Let me copy it. So it's x divided by x plus 2. Very good. Thank you for picking that one. So, like before, we have to start with the function. We exhaust everything, limits, everything, domain, etc., etc., x and y intercepts, and then we go to the derivatives. Okay, so can anyone give us the domain of this function?
It would be negative infinity, negative 2 union negative 2 to infinity.
Brilliant. So what Megan is saying, make sure you exclude negative 2 from everything. Nothing. You cannot write anything under negative 2 forever for this function. Because this denominator cannot be simplified, it stays. I know that x equals negative 2 must be a vertical asymptote. Okay, so now I need these limits. I need the x and y intercepts, and then I can start the first derivative. So I'm going to determine these limits first. So on page 7, it's a lot of work with these functions. So limit as x approaches negative infinity from x over x plus 2, and then limit as x approaches infinity from x over x plus 2. How do we start this limit? Like this one as well. What do we have to do first? Where does the numerator go?
Negative infinity.
Good. Where does the denominator go?
Also negative infinity.
Good. What method we have for something like this? In a fraction, L'Hopital's
rule.
Very good. So let's differentiate the top.
1.
The denominator.
Also 1.
That's it. So this is also the same thing. So we have to say that y equals 1 is a horizontal asymptote. 1, 1, and I make myself a note, y equals 1, horizontal asymptote. Now I need these limits. So limit as x approaches negative 2 from the left of x over x plus 2, and limit as x approaches negative 2 from the right of x over x plus 2. Where does the top go? It's negative 2, right? The denominator has to be 0. The top is negative 2. The denominator has to be 0. So I know this must be the answer, but I don't know the sign. Can anyone give us the sign for the first one?
Is it negative?
So negative 2 from the left is negative 2.1. Negative 2 over negative 2.1 is positive. What about the other one?
Something like 1.9.
Negative 1.9.
Negative 1.9.
Yes. And the sign?
Positive.
Yeah, negative. So it's negative 2 over, so if this is negative 1.9, this will cover it. So the top is negative and the bottom is positive. That's why we get negative. So x equals negative 2 is a VA, as we already knew. So on the left is infinity, on the right is negative infinity. X and y intercepts. How much is f of 0?
0.
Very good. And there is no reason for me to find this because I will get the fraction is 0 only when what is 0? a fraction is 0? Only
Only
when?
when the numerator is 0.
When the numerator is 0, which again, we come back to this. We exhausted everything about the function. So it took us like 5 minutes just to finish the function first. We haven't even gotten to the first or the second derivatives. Okay, so tell me which rule we apply for this function.
The quotient rule.
Very good. The denominator is x plus 2 squared. The top is 1, and then x plus 2 minus the top times the denominator is minus x. Very nice. So this is 2 over x plus 2 squared. Does this function, is the f prime ever 0?
No.
No, never. Because the numerator can never be 0. What is the sign of this expression?
It's always positive.
Always positive. What does that say about the function?
It always goes up.
Good. Will it have a max min?
No.
No. Now this is the moment of truth. This is when I catch my mistakes. If these two rows don't work well together, then I'll say oops and go back to the drawing board. From 1 to infinity, what does the function do?
Increases.
Is that supported by the sign of the derivative?
Yes.
Good. From negative infinity to 0 and then to 1, what does the function do?
Increases.
Is that correct?
Yes.
Good. Let's look at the second derivative. So this is the first derivative. Of course, I will change it into this because this is so much easier to differentiate. Can anyone tell us the second derivative?
-4 times x plus 2 to the -3rd.
Times the inner function prime, which is 1. So this is -4 over x plus 2 to the 3rd. Is the second derivative ever 0?
No.
No, never. What does that mean? That the function will or will not have an inflection point?
It will not, because it will never go negative.
Very good. So now, we need to study the sign of this. So please, to the left of -2, plug in a number and tell me the sign. To the right of -2, plug in a number and tell me the sign. So plug in a number to the left of -2, like -10.
It's always positive.
No, that side is positive, which means opens up. So let's plug in 0. To the right of -2, let's plug in 0. What sign do we get?
Negative.
Yes. So always remember, if the power is 3, anything can happen. If the power is 2, no, it's all positive. But if the power is odd, we cannot conclude. You have to check. Done. The table is done. We are ready to graph. I don't care for any of the calculations anymore. All I care about is the table. The table tells me everything I need to know. When I graph a function with asymptotes, what do I have to graph first? Always
The lines of those asymptotes.
the asymptotes. Very good. So first is y equals 1 and x equals -2. So I have to, if a function has asymptotes, the first thing I have to graph are the asymptotes. They are not part of the graph. They have to be graphed, but they're not part of the graph. So now the table says from 1 to infinity on the left-hand side of the vertical asymptote, opening up, increasing. From 1 to infinity, increasing, opening up. It cannot be easier, I think. On the other side, I have the point 0, 0. Always opening down, always increasing from negative infinity, passing through this point, going towards 1. No problem. So this is the function x over x plus 2. Yes, you can go and check if that's what you want to do, but we are not learning if we start by graphing with the graphing calculator and just trying to fit this and that. Please don't. So the numerator is just one term. I will not put it in parentheses, but if you don't put the denominator in parentheses, you will not graph correctly. It will give you something else. The calculator will not put the horizontal asymptote. You have to enter it yourself. And I'm going to use Zoom 6 as the standard viewing window. So as you see, it does not appear, the graphing calculator does not show the vertical asymptote. I don't know why. Maybe there is a way of putting it in on the software. But we already know the vertical asymptote is at -2 and the horizontal y equals 1. So you can always go back and check. You really don't need to, because the table tells you everything. Once you fill in the entire table, your graph should be correct. 2.3 is not finished. I still have to show you